Hi everyone, I am Pedro Hernandez and I am a data scientist at the Institute of Data Science at Maastricht University.
Hello, and I am Laura Robinson. I am a research assistant also at the Institute of Data Science of Maastricht University.
And today we're going to present you our working paper. It's titled PolNetCast. It is a policy networks forecast framework, and it motivates the case for computationally forecasting the evolving interactions of the judgments of the EU and the legal acts to anticipate policy adoptions.
So to give you a bit of an outline of what's coming next, first we're going to give you a brief overview of the policy-making lifecycle in the EU, and this will lead into the challenges regarding transposition of EU laws in member states, specifically directives, and these are some of the challenges that we want to tackle with our research. We'll explore the research question and significance of our research, present to you the proposed methodology, and then finally end with a brief summary and a summary of our next steps.
Okay, let's start from the beginning. The European Union is a union of 27 member states by the moment, and we want to explore how, because they basically bring development through policy, either economically or politically. We might see that the EU brings this cycle of chain action and reaction life cycle, right? So within this context, we can define that EU policy is national governmental actions and initiatives that are introduced in response to these pieces of legislation. We see that Keating proposes in 2007 how the EU life cycle looks like. It starts from the development, it goes to the general decision, it's been transposed and therefore implemented and ideally evaluated. This cycle we can see in three axes. It goes firstly in preparation, it goes into a decision-making process and is implemented into different levels at the EU level and a national level. In the preparation phase, we can see that everything starts from the interest groups and the national ministries. This goes then into the Commission expert groups that normally are interlinked or they are in highly communicated setups. Therefore, it goes into the working parties, and here's where all these legislative drafts and green papers and white papers are drafted. Therefore, you would have trialogues and conciliation committees of how new laws and policies or merge of different directives can be achieved. Therefore, in the national parliaments, they would have a green light. It comes back then into the Commission and they release formal statements, and finally it will be released and implemented as a regulation directive of decision in different member states. And if we go deeper, we see that implementations follow this waterfall effect, where actually the policy or rules that are drafted or released, they have to be interpreted by each one of the member states and therefore create actions. So in the case of directive, you would have transposition instruments, and depending on the infrastructure, either administratively speaking or politically speaking, they would differ of how to implement, right? And it doesn't matter if it's regulation, at the end, you would have these regulatory bodies or agencies that they will foresee and seek and aim the adoption, and therefore go all the way to the citizens.
So to give you two examples, just to make this a lot more concrete, we first picked the Parental Leave Directive that was introduced in 1996. The deadline for transposition by member states was set for 2 years later, but also note that it was repealed in 2012, so this one is not specifically in force right now, but it's the predecessor of a revised directive. Ultimately, what it aimed to achieve was set some standards for parental leave, and it guaranteed that both mothers and fathers would be able to take a minimum of 3 months parental leave and have their jobs kept for them when they return. Ultimately, this directive, it provides certain guidelines or standards by which the member states have to abide, but it doesn't tell member states how those member states have to transpose the directive and how they have to implement different changes. And it creates adaptational pressure within the member states, and the extent to which the member states have to make changes depends a lot on their existing institutional and regulatory structures. Ultimately, they usually introduce policies. And as we can see with this one, Finland, Sweden, and the Netherlands managed to transpose the directive on time. Luxembourg managed to do so within the extended deadline, but Austria, Italy, Germany, and a number of other countries transposed the directive late, and this is problematic. As another example, we have the EU Data Protection Directive of 1995. Again, this one was repealed in 2018. It's actually the predecessor of the GDPR. But it was adopted in 1995, and the deadline was set for 3 years later in 1998. This directive aimed to sort of strike a balance between personal data protection and privacy and free movement of data within the EU. Again, it created adaptational pressure in different member states, and the extent to which different member states had to adapt and make changes depended on their different structures again. And ultimately, many member states introduced policies and made changes to their legislation. Italy and Spain were two of the countries who managed to do so on time. However, France, Ireland, and Luxembourg were very late, and in fact, the European Commission started enforcement proceedings against them, which are of course very costly. So as we can see, there are member states who managed to transpose directives on time, but there are also many who happen to do so late. And if we have a look at this graph, which was published by Keating in his article of 2006, we can see on the horizontal axis, there is a nice division between directives which are transposed early or on time and those which are transposed late. And only about 40% of directives were transposed on time for Germany, Greece, Spain, the Netherlands, and the UK within his time period. So there's a considerable transposition deficit, and this is a big problem. Firstly, because delays incur penalties, and this is of course costly, firstly for the European Commission, but also for the individual member states themselves. And furthermore, delays block citizens from receiving the direct benefits of EU law, which is supposed to be made in their favor, so this is problematic. However, we also see that there is an opportunity here for large-scale data-driven technologies to assist decision makers. If we have a look, data has already been used by the European Commission. They have been busy developing key performance indicators to track individual member states' performances regarding transposition of directives. This graph shows a change in the average transposition deficit over time. We can see, for example, there was a peak in 2016 because of an unusually large number of directives that needed to be transposed. But ultimately, this one is very descriptive rather than predictive analysis. And so we are aiming for a slightly different approach of using data to relate it to policy and law.
A bit of a refresher of how data science is being used. We see that the evidence, more like in a classical way, the evidence-based policy making basically replace the ideologically driven politics. And it goes all the way into a rigorous and systematic approach. And this is basically setting up experiments, normally with test and control groups, and you will see whether a law or a policy will work or not. And then you would basically set up a discursive set of methods and methodologies that will inform the policy process, right? And this basically will minimize the risk of mismatch between the government expectation and the actual on-the-ground conditions. In the other side, we see there is more, it's being explored nowadays. This is another approach of policy analytics, where you would combine law and policy with data science methodologies, right? So where you would develop and bring applications and new applications and methodologies, so that we can aim and support relevant stakeholders that they are engaged in any of the stages of the policy cycle. So these ones will facilitate insights and foresee in order to make more preventive actions. These technologies have to be meaningful, operational, and has to be legitimating, ensuring the transparency and accountability of the whole life cycle. Here's where we ask the research question, right? Can computational methodologies assist to overcome policy adoption issues, as we explore in examples. We can branch out into sub-research questions. Can actually a machine learning model trained on the topological features of a citation network can forecast future network topologies? And if so, what are the limitations of representing policy adoption issues as properties in the Court of Justice of the EU network? For this, we propose the PolNetCast framework. This is a computational approach that will basically generate predictions regarding future litigation events, but those that are related to EU law releases and new legislation. So that will enable policymakers of member states foresee future issues, right? So imagine that you are a policymaker in Italy, in Spain, and Malta, and you will have this piece of technology that will help you to foresee whether if in a certain point of time you would have a certain probability of delay or certain probability of issues in interactions of the policy implementation.
So before we go into our specific methodology, we'll just touch briefly on some related work. So firstly, there are a lot of network analyses of EU case law and their citations. However, these firstly do not track network evolution, and furthermore, they focus only on case law, so they don't link the case law to related legal acts such as directives or regulations. Furthermore, there is evidence that legislation, so the mandatory EU acts, respond to case law, and these also influence policies. However, the explicit link between all of these and influences are largely overlooked within research. And if we manage to connect these three, so connect mandatory EU acts with the case law and use it to predict policies and have an interaction between these three different laws, the question is, what do we want to do with this? And ultimately, we want to address the transposition deficit that we mentioned beforehand. Now, there's already a lot of research on why transposition in member states is often delayed. However, a lot of this aims to understand all the different factors which contribute to delays. And we mainly want to focus on specific features and see if they can still create a predictive model that can be useful for decision makers.
So this is more or less how the proposed methodology looks like. You would have these very 5 broad phases where you have the data acquisition, we develop the network, you add the feature of the time, you train, and then we forecast. Let's start from the beginning. So you have the EURLATES database, where it's the gold standard data source for EU legal acts and also all the case law and litigation events. You also have there, you have the treaties, you have all the referrals, you have all the appealings, pretty much everything. And this is more or less how a document looks like. This is the GDPR regulation, where you would have the meta information of the piece of legislation, or if it's enforced or not. You would have the dates. That's very important. But most importantly, you would have the related documents. So you have a relation between this GDPR with case law, and this is a connection. And you would have also this GDPR that is referred to the old Directive of Data Protection. And this comes into how the network is shaped, basically, right? So we take into account these 3 types of legal acts, where the nodes will be all these cases and litigation events, and also the laws. And therefore, all these referrals and citations will be the edges, right? So therefore, you would have, in a way, as imagine that you have the subgraph of the data protection issues, where the Directive GDPR is connected all the way to the cases where you would have enforcement proceeding in different member states, right? It's all connected. How we add time into the features? Well, you would have in the documents the time where the document was released. So imagine that we would go to the data protection in 1995, and the network has a shape. This subgraph would have a shape, right? So here's where you take a snapshot in time. You go to the next time interval, next month, let's say. and the network already evolved and changed. Then you take another snapshot in time, and so on and so forth till the present time. So you would have these very specific network snapshots of the evolution in time. And for those who are familiarized, we're basically splitting a cross-sectional data into a panel data of networks, the snapshots of different policies, right? Once you have all this data, is basically you were talking basically big data, because imagine for each one of the relations, we're talking right now more than 140,000 of EU legal acts, and in average you would have between 50 and 200 referrals among all those legal acts. That times all the snapshots in time. So we are talking about more than 50 years. So this is really big data. And if we account the features, you would basically take one snapshot, you will calculate the topological features. Those can be the network connectivity, like the betweenness between among nodes, the node degree, the sleeping or awakening coefficient, also speed of change, because here we want to be able to see whether if this network is evolving quicker than other, right? We aim to implement an XGBoost framework for forecasting time series. In this case, the time series we want to forecast are the features of the topology, so that past network can come into a future network, and this future or time ahead subgraph will come up. Will bring you new outcomes. This outcome can be like, for example, a court case of certain member state with certain probability, but also can be that we can see these new interactions in the subgraph, and these new interactions might indicate a delay on the transposition. In a nutshell, this is how the Paul-Netscast framework will look like. Some of the innovation that we can see here when let's say a stakeholder or a policy practitioner or a legislator would use is that you point yourself in a point in time, and your input will be the legislative proposals, right? So if we see that policy making takes time, if we talk about, let's say, for example, the Paris Agreement or whatever, from the very first draft till the law is released, it can be 1, 2, 3 years in time. All these snapshots evolutions, we will use it as an input. We calculate the temporal features, and therefore we can have a future network topology. Some of the innovation is that we are actually using the extended citation network of the laws and litigation, and to our knowledge, forecasting the topology is unexplored, or naturally this is a data-driven decision tool, and we are advocate of the implementation of FAIR principles on the data management of the framework.
So if we look at the potential benefits towards policy making of Paul-Netscast, well, firstly, we would hope that it would assist decision makers by forecasting the interaction between mandatory EU laws, case laws, and then policies that need to be introduced. With this, we hope that policymakers will be able to foresee the negative consequences or potential delays in policy adoptions, and therefore use that to take preventative action and aim to minimize any policy mismatch. Ultimately, we also hope that the whole framework assists researchers to understand the explicit interactions between mandatory EU laws, case laws of the EU, and policies that need to be implemented within the individual member states.
So far, we have motivated the case for computationally forecast the evolving interactions, the Paul-Netscast framework. Naturally, you might be wondering that there is a lot of external factors that explain the issues on policy implementations, and that actually more or less why we want to isolate all those factors and look at the interactions themselves. Can we can the interactions between litigation events and the network snapshots on time tell us something about the issues on delays? And of course, these studies has the potential to lead us closer to provide aid for future legal and policy decision making. So far, we have gathered the data and sampled a chunk of cases for a use case, just like the examples we mentioned. And right now we are setting up a systematically to review on using computational methods to study policy adoption predictions. And yeah, of course, we are very enthusiastic to be part of the data for policy community, and we are so super open for collaborations. Thank you for listening.
Thank you.